Hello. Hello. Today we're going to examine the graphs of sine and cosine. So if we look at the different graphs, we've got y equals sine of x here over on the left, and you can see that it goes straight through the origin versus the cosine graph, which starts at y is 1. When we're looking at the domain of these graphs, however, this graph continues on forever in both directions, and so does the cosine. So the domain is the whole real line. So we write from negative infinity to positive infinity. The range are the y values. So I look at this graph and say, okay, my y is taken on by sine and also cosine go from 1 to negative 1 to 1. Please make sure you're using brackets to include the negative 1 and the 1. The amplitude is the distance varying from the center line, and the center line we can call the sinusoidal axis. The center line in both of these cases is the x-axis, and so the variation from the center line is 1 unit above and 1 unit below, so the amplitude is 1. The period is the length it takes to create one cycle. So if you look at a period of cosine, you start at its max, you go to its other max point. If you look at the sine, you can start at the origin and go back to the x-axis. Those are what we call a cycle of sine and cosine. And their period is 2 pi, sorry. And you can probably remember that from our unit circle going from 0 to 2 pi. All right, so this is our general transformed sine equation. We have the a, the b, the c, and the d, and they both represent some sort of transformation. The a we call the amplitude. Okay, and it's going to also be called the vertical stretch or shrink, right? The b deals with the period. So to calculate the period, we take 2 pi divided by b. Another way of looking at b is the number of cycles between 0 and 2 pi. Okay. C is the horizontal translation, or the phase shift. And D is the vertical shift. All right, so let's look at an example here. We've got 5 cosine of 2x. The number in front is 5, so our amplitude is 5. Our period we can find by doing 2 pi divided by 2, and so therefore our period in this case is is pi. Now we need to sketch it. So since it's not vertically shifted, we know the sinusoidal axis is the x-axis, and we go up 5. 1, 2, 3, 4, 5. We go down 5. 1, 2, 3, 4, 5. Since it says sketch, I can be kind of lenient here with my scaling. It's a cosine curve, so it starts at the top. I'm going to go ahead and just draw in one cycle. Okay, and I know my cycle needs to end at pi because the period was pi units long. And so then halfway through will be pi halves. This will occur at pi fourths. I'm just dividing each section by 2. 3 pi over 4, 3/4. So 1/4, 1/2, 3/4, 1. And it goes up to 5 and down to negative 5. Okay, now I have negative sine x divided by 3 plus 2. Be careful here on the amplitude. A lot of people like to say it's negative, but if you remember how I defined amplitude, amplitude is a distance, so it is always a positive number. So in this case, it's a positive 1. The period, again, we're going to take 2 pi divided by 1/3, right? Because this can also be written as 1/3 times x. And we never divide by fractions, we multiply by the reciprocal. So that ends up being 6 pi for my period. Another transformation we can see here is the vertical shift. So it's up 2 units. And this negative is a reflection over our x-axis. Okay, so now if we want to sketch this, I have the idea that I need to have a sinusoidal axis of 2 because it went up 2, so our axis would have been the sinusoidal axis, or our x-axis would have been, but now since it's shifted up, I'm just going to go up 2, draw a dotted line because that's my middle. And then I know sine, the amplitude is 1, so from here I go up 1 and I go down 1. Again, you might even just draw in the penmanship paper so you know what your graph has to stay between. Okay, then we can draw a cycle of sine, being careful to do the reflection. So remember, sine always starts at the sinusoidal axis. It generally started at the origin, but since it's shifted up, it's going to start at 2. And then it starts up, but since we had the negative, it's actually going to start down. So we're going to and right where it crosses the sinusoidal axis again, that's going to be the length of your period, which will be 6 pi. So then you can see, and this is going to be 3 pi halfway between, and then you can keep cutting these in half. So this is 3 pi over 2, etc. Lastly, we want to be able to get an equation from a graph. So we look at this and say, okay, it's looking like its sinusoidal axis is -1. It looks like it goes up 1 and down 1, so therefore its amplitude is 1. It starts down, so I'm going to say it is a negative sine graph. Again, if you decided to shift it right and left, you could call it a cosine graph, but I'm just going to start here down, call it negative sine. My amplitude's 1. The length of one cycle is from negative pi halves to pi halves. So that distance right there would be pi units. So I know my period is pi, and remember we get b from doing 2 pi, or we get our period from doing 2 pi over b. So to find b, that means we need to do 2 pi over p. So my b is going to be 2 pi over pi, which results in a 2. And so then we decided not to shift it, so there's no horizontal shift, but it is moved down 1 unit, so I write -1, and there is my equation. Again, compare that to the general y equals a sine or cosine b x minus c plus d. So our vertical shift was -1. We decided not to have a horizontal shift. We found our b using this formula right here. B equals 2 pi over p, and our amplitude from the varying distance. All right, I hope this helps you enough to do your homework. Make sure you ask questions if you need to. Have a nice night.